Okay, good morning, good evening, and good afternoon. Here is the second question. It says that prove using mathematical induction that the sum of these perfect numbers is the same thing as n into n plus 1 into 2n plus 1 divided by 6 for all n in natural number. And that is we are to prove that sum of this is the same thing as this using mathematical induction. And to prove this, we are to show for n is equal to 1, for n is equal to any arbitrary positive integer k, and for n is equal to k plus 1. This is what we are to show. We are to show for n is equal to 1, n is equal to k, and for n is equal to k plus 1, where k is any arbitrary number from integer. Okay, let us show this. For n is equal to 1, let's show this with our right hand side. So our right hand side is n into n plus 1 into 2n plus 1 all over 6. Then for n is equal to 1, this one is the same thing as, wherever we see n, we'll put n in terms of 1 in this equation in order to prove it. So we have 1 outside here, 1 into 1 plus 1 close bracket 2n, that is 2 multiplied by 1 plus 1 plus 1 close bracket divided by 6. From here you can see that 1 multiplied by 2, because 1 plus 1 is 2, multiplied by 1, it will only give us 2. Multiplied by 2 times 1 is 2 plus 1 is 3, 2 plus 3, 2 times 3 is 6, divided by 6, it will give us 1. That is for n is equal to 1. And for n is equal to k, let us assume this k is any arbitrary integer, positive integer. For n is equal to k, we're going to have 1 square plus 2 square plus 3 square plus dot 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 up to k square. And this time around, instead of writing the n, we will write k, since we assume that the k is any arbitrary number from the given integer. And this one is nothing but k into k plus 1 into 2k plus 1 close bracket divided by 6. This for n is equal to k. And for n is equal to k plus 1, that is, we have to show that a 1 square plus 2 square plus k square plus k plus 1 square is the same thing as, wherever we see n, we write k plus 1 instead of only n. We have k plus 1 here into k plus 1. Already we have our plus 1 here. Then this one, it will tend to k plus 1 plus 1 is 2. So instead of writing 1, we write 2 close bracket into 2 outside. Then n, it will be k plus 1 close bracket n plus our 1 close bracket all over 6. That is 2 times k is 2k, 2 times 1 is 2, plus 1 is 3. Then this much, it will give us 2k plus 3. So we have to show that this one is the same thing as this. Okay, let us use this one instead. From here, since we see that our a is 1 square plus 2 square plus 3 square up to k square, this much, then let's apply this again, plus k plus 1 square is the same thing as, I will write this one, since we add k plus 1 square, let's use a balancing method. I will put it, or I will write it again here. Let me reduce this one small, right, so that we're going to have k into k plus 1 into 2k plus 1 close bracket divided by 6 plus, since we said that this one is the same thing as this, so we have this one is the same thing as this, plus k plus 1. We will add it to this side in order to maintain our balance. Okay, now all the operation, it will be in our right hand side now. Let's take our right hand side. Our right hand side is the same thing as k into k plus 1 into 2k plus 1 close bracket plus, since this one is not in fraction while this one is fraction, which means the LCM is 6, because this one is the same thing as divided by 1. The LCM of 6 and 1 is 6. 6 into 6, it will give us 1. 1 multiplied by this much, it will give us this. Then plus 6 multiplied by this. So that you can write this one as 6k plus 1 square. Don't forget, divide by our 6. Okay. As you can see that from here, we have k plus 1 here. All this one, they are product. We have k plus 1 here, and we have k plus 1 here. We can factor out 1, k plus 1 outside. And this one is the same thing as k plus 1 outside. Then, what will remain here is k into 2k plus 1. K into 2k plus 1, close bracket, this much. Then plus, we have k plus 1 square here, then it will turn to 1 since we factor out k plus 1 outside. Then this one is going to be 6 into k plus 1, close bracket, close our bigger bracket, divided by 6. Okay, let us simplify this one. This one, we have our k plus 1 outside, then into k plus 2k, k plus 1. This one is going to give us 2k square plus 2 from here. Then plus, okay, k times 1. It's not 2, is only k. Then plus 6 times k, it will give us 6k. And from here, 6 times 1, it will give us plus 6 plus our bigger bracket 1 over 6. And this one is the same thing as k plus 1 into 2k square. We don't have any square here. Then we write it like this: 2k square plus 1k plus 7k, it will give us 7. 1k plus 6k, it will give us 7k. Then we write this one as 7k plus our 6, close bracket, divided by 6. Okay, let us use a quadratic method to solve this one. We have 2k square plus 7k plus 6. We can factorize this because 2k times 6, it will give us 12k square. And this 12k here square, we can write it as a sum of this 7 by writing 4k plus 3k. If you add 4k plus 3k, it will give us 7k. And if you multiply 4k multiplied by 3k, it will give us 12k square. Therefore, our factors are these. And if you have this as factor, instead of writing this, we'll write this as 2k square plus 4k plus 3k plus 6. As you can see, we didn't change anything here because if you sum this 4k and 3k, it will give us 7k. But we expand this in order both the side to get its part, so that we have a factor here, a common factor here, and that is 2k, because 2k can enter 2k square, can enter 4k. Factor out 2k outside, we have k plus 2, because 2k times k, it will give us 2k square. 2k times 2, it will give us 4k plus 3 is factor here and here, so that we're going to have this one as k plus 2, close bracket. From here, we can see that we have k plus 2 as a common factor. Factor out 1k plus 2, open bracket, write our 2k here, write our plus 3. This one. So instead of writing this one, now we will write this one. I hope you understand the simplification. Okay. Then, this much, I can write it as k plus 1 into 2k plus 1, close bracket. As we simplify it, here we can see into 2k into 2k. Okay, we have k plus 2. We have k plus 2, please, into 2k plus 3 divided by 6 as required. As you can see that here we end up at k plus 1 into k plus 2 into 2k plus 3 divided by 6. As you can see it here, we have k plus 1 into k plus 2 into 2k plus 3 into 2k plus 3 divided by 6. Hence the proof. because you can see that we have showed now, which means